build a simple Hello World React Node app and test it with Yarn, move it into a Docker container, test it on your local machine with Docker, and then move it to Amazon Elastic Container Service, build an ECS cluster, and access it from ECS, and then integrate SSL so that we can secure the front-end load balancer that will be serving traffic to your ECS cluster. So let's go ahead and get started. First thing you want to do is you want to clone down a React app. It could be any app really, but the one that I chose was from a guy named, so I can pull this up here. Let's see here. Well, as soon as my computer loads. There we go. It's from a guy named Safik, I believe is his name. There's a YouTube repo, and in here is a Hello World app. Very simple, and you can go ahead. I'll put the link to his GitHub in here. It was very helpful, so Safik, if you're out there, thank you. And you can go ahead and clone this down yourself. So I cloned this down to a just a directory. I'm calling this project Bonobo. And in this directory, I basically get my public, my source, a yarn lock file, a package.json, a readme, and a get ignore file. So that's what I started with. So with just that, you can do the following. Oh yeah, I'm in Windows. After I find it. Docker, local, Bonobo. That's what I get for being on Linux all the time. None of my Linux commands work. I suck at Windows, and I am not ashamed to admit it. Okay, so now that I'm in here, you can see, let me go down one more, that I have all of my files here. I can run yarn and make sure that I get all my packages resolved, and then yarn start. And yarn will go ahead and start up a browser on port 3000. The React scripts will run. And essentially what this does is there's an index.html file that doesn't do a whole lot. All it really does is just has this script, and the actual app itself just has a root of hello world. That's all it really does. And then the index.js file, kind of helps it do the same thing, which it's loading because my computer just woke up this morning. So once this runs, then what you should be able to do, and it's not running yet, it'll kick off a development server, and then we should see a new tab open with that hello world page. All right, there it goes. Starting development server. All right, so let's go ahead and try it. Localhost, port 3000. Apologize that mine is going so slow. Stop, refresh. And there we go. React app, hello world. So the app works on my local machine. So let's say you want to containerize your app. Well, so to do that, the next thing you do is you set up a Docker file. And in my case, I just built this little Docker file to get the latest LTS Alpine from Node as build. create an app directory, set a path for my node modules, and then I copy the package.json file from my local machine along with my yarn lock. And then in my container, I run yarn, and then I copy everything in this, so everything from the repo that I cloned into the /app directory in my container, and then run yarn build, which is like yarn start, but for more like production stuff. Then I get 1.21.4 Alpine Nginx, and then copy from build, this is as build, everything app build and to an Nginx HTML share directory. I get rid of the default Nginx config. I copy the Nginx config that I'm going to show you in a second into etc nginx conf.d, expose port 80, and then go ahead and start it up. So what you need to do is you need to have a Docker file. And since we are doing like a copy everything kind of thing, copy everything into app, you also need a Docker ignore file. And your Docker ignore file will just say, hey, ignore node modules because that's a huge directory and you don't need that because we're going to run yarn in the container anyway. Ignore my Docker file because we don't need to move that over. And ignore all the get anything.get stuff. So then you need to create an nginx directory. This is all in the same root path too, inside my Bonobo folder. And in there, you'll create an nginx.conf, and I just have a simple server listening on port 80 set to index.html, etc., etc. And just to go show you one more time, I'm using that to copy from my local machine to that nginx directory in the container. So that's pretty much it. So I'm going to go ahead and stop yarn, and then I'll go over this for you so I don't skip any steps in case you're following along. You need to build your Docker image from the Docker file, and once you have that done, you should be able to see here I have Bonobo. I called mine local, and then you can have you can take that container or that image and you can create a container with Docker run. And once that's created, you can do a Docker container ls, and you can see I have nothing there. But if I do -a, I can see, oh, look, this thing's been run a bunch of times. Exited, created, exited, created, exited, created. So now I have to see if I have anything running. You can do that with Docker ps. There's nothing running. So that I can go ahead and run mine. So I'll do Docker run interactive tty detached map port 80 to port 80 in the container, and I want to use my Bonobo local latest. So what this will do is it'll create that container to be run, and if I do a Docker ps, I can see that that's now running. Since port 80 is mapped from my machine and it's saying allow, basically forward anything on port 80 to port 80, and this is running on my computer, on my PC, then what I should be able to do is go hit localhost on port 80, and I get the exact same thing. And I have the React app title up here. My body looks good. The text font's the same. Everything looks good. So what we've done is we've just containerized this app really just by copying everything and configuring a Docker container to run on my local machine. So the adage, well, it works on my machine, is never a good thing, but if it works in a Docker container, you're far more likely to have less problems. So now we have this containerized, which is awesome. The next step is we're going to create an ECS cluster. Some of these resources take a while to provision, so I went ahead and took the leisure to create them ahead of time, so you don't have to wait. So you're going to create a networking only cluster, give it a name, slap it some IPs with a new VPC, because it'll create a new VPC. You put in a tag, and once you hit create, it's going to build your VPC, your route table, your routes, it's going to attach everything. It'll build your entire network for you. Then what we do, actually, before I do that, I'll show you So in ECS, I built a cluster called Bonobo, and here it is, and it's running, and everything looks fine. So you should end up with a cluster once you're done, and you'll get a little screen that looks like this. So then what you need to do is create an ECR repository. So ECR, if you're not familiar, is the Elastic Container Registry. And it's kind of like Docker Hub, where you can put your containers here, or your Docker images here, and use this image to build things. So in our case, an ECS cluster. So you'll just create a repo, and I have all that in here. Make sure it's private, give it a name, leave everything as default, click a repository, and then when you get here, you can select it and click View Push Commands, and it'll give you all the commands to create your authentication, to do your Docker build, to do your tags, and then a Docker push. And Docker push will push this container to your ECR repository for you to use later. So then once you get that set up, you create something called an ECS task definition. So in ECS, you have your cluster, right? Well, inside your cluster is just kind of like the generic, like this is where we're going to host everything, right? With your nodes and all that stuff. Well, then you have to create a task definition. So a task definition, as you can see here, they specify container information, like how many containers do you want? What resources do they use? How are they linked together? What ports do they use? So it's just like everything you would expect in a file that would tell somebody how you want your infrastructure to be run inside of the cluster. So in my case, what I did was I gave it a name, set to Linux, and I put it on Fargate. And if also you're not familiar with Fargate, it's basically like managed EC2. So with an EKS cluster, and it creates like actual, well, you can do EC2 here too, but you create EC2 instances, you still have to manage them. But Fargate is completely managed service, so you don't have to manage the compute nodes behind your cluster. These roles are pre-populated, so you can go ahead and just select these ones. I selected the smallest half a gig memory, quarter of a CPU, a vCPU that they offer. And then what I did was I pointed it at my ECR container so that when I'm telling it a task definition, I said, hey, use Fargate as a backend. Here's how much resources I want to use. And in that cluster, I want you to run this ECR image. I want you to make a container out of that. And then that's pretty much it. So I have all the instructions here, and really the only trick is you got to copy the URI of your container image, which you'll have to have probably like 2 windows open for most of this stuff, and set up your task definition. So once you have a task definition to define how you want your infrastructure deployed or your app deployed inside of your cluster, you need to make a load balancer. I've done this a million times, so I'm not going to take a bunch of time to do it, but basically the only difference is you need to set up your cluster so that your VPC that you're using is the same one that ECS created. So double check your VPC ID. An easy way to tell also is by the CIDR address. I gave mine I don't usually use 192.168, so it's easy for me to recognize. Make sure you add both subnets, and then you create a security group. I started out with this HTTP, and then assign that new security group to your load balancer, create a target group, assign the target group to the load balancer. A lot of this stuff is kind of pretty generic. The only thing is, so for type for the target group, normally you choose instances. I chose IP addresses, and then I just gave it some random IP. I just gave it a .10 for the last CIDR block because that falls in the subnet range or the VPC CIDR range. And once I have resources and it goes in there, I'll just delete it. But in order to select this, you have to put some kind of address in there. So that's what I put in there. Include that as pending below, create the target group, assign it to the load balancer, hit active, make sure you have a listener, and then you should be good to go. So in my case, we can go ahead and just take a look really quick. Your load balancer is going to be under EC2 and at the very bottom, load balancers. And then here is my load balancer. And I can look at my listeners, and you can see we need to add a listener for port 80. So I'm going to go ahead and do that. Port 80, forward to my target group, add. View listeners, boom, looks good. So you have now a DNS name that you can use to hit your load balancer. The load balancer is going to balance traffic to a target group that you created. The target group is pointing to, remember I put in that dummy address? To the dummy address. And now it's gone. And so if you're building this, you won't have anything except the dummy address. And so how do you get something in the target group so you can actually go to the load balancer? Because right now, if you went to the load balancer, well, this one does work because I have one in here, but it won't work. So what you need is a service. This is the last part. So you create a service to run the task within the container. So this goes one level deeper than your task definition. So you go to your cluster, and then under services, you create a new service, launch type Fargate, Linux, tell it which task definition you're using, give it a name, and then you tell it how many tasks you want. So it just depends on the traffic, right? And you can set this to auto scale, but I didn't do that in this because I don't need to. Select the VPC, security group, the load balancer. So really everything you've created up to this point, your target group, your ports, all that stuff, you're going to add this to your load balancer. Oops. So that's how you'll get your service all connected to the load balancer. There we go. Add a load balancer. And then once that's been added, you can go back to your cluster and wait. Your pending tasks will go from 0 to 1. So let me show you what that means. So in ECS, if I go to clusters and I click on my cluster, there's a services tab. And you see I have one created. But if you click create, this is all the stuff I was just talking about. So you go through and basically fill this whole thing out, next step, and then you'll end up creating it. And what you'll see is it'll take you, you'll have desired task 1, running task 0 when you first create this. Well, if I click on my cluster, what you'll see is services 1, running task 0, pending tasks 1. And as soon as the service gets started, and you can just hit refresh, or it has an auto refresh or whatever, you should see pending task 0, running tasks 1. As soon as you do that, since this service is pointing to the target group, or utilizing the target group, then as you saw before, your target group will have those resources registered. And then when you go to, that's localhost, when you go to your endpoint, for your public DNS name of your load balancer, you'll get back the same text, hello world. And I like to do a different text because then I know for sure that like everything is working as far as config stuff goes. So now you have an ECS cluster behind a load balancer, which is awesome, right? So I took another step further, and what I did was I added this to my domain. So I just created an A record and put a prefix on it, and then had an A record alias pointing to my cluster, or to my load balancer from my cluster. So then, instead of using this garbage, I can type ecs.nimbusdevops.com with HTTP, and we can see that that works. So that makes it a little cleaner, right? A little bit better. So then the last part is, if you go to Certificate Manager, you can request a public certificate, and you'll want to put in yourdomain.com and star.yourdomain.com. That way your domain has a cert, but also if you create any prefixes like I did, you can also use that same cert for that. Select DNS validation. That is very important because if you're hosting in Route 53, it'll just have a button where you can create records in Route 53, and it'll add these to Route 53, and then it'll be able to verify that cert for you, and it'll be in the pending validation status for a really long time. Mine took like overnight. It could be 30 minutes. It says up to 72 hours, so it might take a while. But this is essentially what it looks like. So we're trying to set up SSL so we can change our load balancer to be HTTPS. So here, you request a cert, request a public cert. Next, you put in your fully qualified domain name, DNS validation, request. Really that simple. Then you can go to your cert and go create records in Route 53. And as you can see, mine were created in Route 53. And after waiting for a very long time, they came back status success. So that's what that is. And in Route 53, you can see the record here with value. This is the ACM validation that was sent by clicking that create records in Route 53. So that's what that is. That's how that works. And as soon as you have that set up, then the next thing you do is go to your load balancer, and on the listeners tab, you should have a port 80, a listener for port 80. You have to create another one for port 443. So here's my load balancer, and then listeners, and then you add a listener, and then you just do HTTPS port 443. The default action is to forward the traffic to a target group, right? And then the listener settings, security policy you can leave. Default SSL certificate is going to be from ACM, and then once your cert is good, you just click on your cert and hit add. And what it'll do is it will add a listener on this port, but there will be a security policy and an SSL certificate that terminates at the load balancer. So then what you do, once this is added and you're ready to go, you can go to https.ecs.nimbusdevops.com in my case, and I can see that I got my app running, I got my domain name, and it's locked. So I have a secure connection. People can come to my site and know that I have a valid certificate. It shows who it was issued to, who it was issued by, when it was created, valid to and from, all that stuff. So this is the standard, the gold standard, if you do anything on the web. So you should have certificates for everything. And you shouldn't be using unsecure sites like this. Most guides I see on the internet don't go through the SSL termination. So I wanted to make sure I included that because apparently y'all that are on my YouTube channel really like SSL. So I'm going to have to make some stuff about SSL. So anyways, so now what we want to do if we want to secure this down a little bit is I can go to my port 80, my listener, and I can just be like, bye Felicia. And now my listener is no longer listening on port 80. So if I refresh this, and it's not in my cache, and we could do one even better, I can go to my security group, which was this one I believe it's using. In inbound rules, I have 80 and 443. Let's go ahead and just get rid of 80. So now not only is it not listening, but there's no security group rule that allows for port 80. So now port 443 works just fine. But if I do http:// my domain name, yeah, my page is cached. There we go. Okay, you can see here it's loading. So it should time out and we should get an error saying page not available. And that's how you do it. So I'll wait for that to finish. If you have any questions, let me know. I hope this was helpful. If you're trying to create a React or Node app and you want to containerize it and you want everybody to be able to use it and then stick it on a managed container cluster with managed nodes behind it, that's all using your your hosted zone DNS, custom DNS name and secured with SSL certificate that's validated by Amazon, this is the place for you. All right, so you can see this is totally bogus and now you can't get to it, but the secure one works just fine. So hopefully this is helpful, and if you need anything, let me know. But if not, then good luck out there and happy building things. I'll see you later.